Hey, welcome back. This is 7.6 and we're in Math 0965. We're going to work with solving rational expressions. So up to this point we've been simplifying things. Now we're going to be solving things. Okay. Okay. Solving rational expressions. Just what I have typed there. Okay, so how do we do this? We're going to do it by multiplying by the LCD of all the fractions involved. So similar to method 2 in the complex fraction section in 7.5. Okay, so multiply by the LCD again. Okay, so let's take a look at what we're up against. We have x over 5 equals x over 6 plus 1. So the LCD, the least common denominator of these fractions, I'll kind of note that first. Basically, it's the least common denominator if you're going to add these three terms together, x over 5, x over 6, and then the 1. But you could also think of it as the smallest number that's divisible by the denominators. Okay, so you need something that's divisible by 5 and divisible by 6. And the least common, the least number that has that characteristic is the number 30. Okay, so that's going to be the LCD. And I need to multiply both sides by this thing. And I'll try to kind of show you how they do it in the book as well. So look at, x 30 times x over 5, and on this other side, and I know in the previous video I would just kind of say kind of do it in your head or do it in the margin. The book will actually write it out. So you'd have 30 times x over 6 plus 30. I don't know, maybe it's easier to see it that way. But then I risk, there's other issues. Okay, so anyways, over here on the left, you could kind of see this multiplication will result in 6x, right? Because 5 will go in the 30 6 times x is 6x. Okay, this multiplication, 6 goes in the 30 5 times x. Okay, and then plus 30 times 1 is 30. And then you can move the 5x over, and you just get x equals 30. And that would be your answer. Okay, so that's, it's an equation, except it has a bunch of fractions in it, and you're kind of looking for a quick way to solve it. Okay, let's look at another one. 5x over 4 equals x over 12 minus x over 2. Okay, so again, like the first thing I'm going to do is identify the LCD of all these fractions. There's more than one thing you can multiply by, right? You can multiply by 24. 4 will divide into it, 12 will divide into it, 2 will also divide into it. But you want the smallest number that's divisible by 4, 12, and 2. So, and 12 flips the bill. And again, you could also think that's, if I was going to add these things up, that would be the least common denominator. Okay. But anyways, let's go at it. So this times 12 and this times 12. On the left, you have then 12 times 5x over 4. On the right, you're distributing, so you have 12 times x over 12 minus 12 times x over 2. Okay, so 4 will go in the 12 3 times, and then 3 times the 5x will be 15x. On the right, 12 go in the 12 one time, then 1 times x is just x. 2 goes in the 12 6 times, so minus 6x. Okay, so on the right, there's a little bit of simplification, combining like terms, you get minus 5x. And then we need to get all the x's on one side, so I'm going to add 5x to both sides. So I get 20x equals 0. And then finally divide by 20, and x will be 0. Okay. Okay. So these first two examples, we didn't have any variables in the denominator. But if there are variables in the denominator, you have to be a little bit careful. Okay, you have to check your restrictions. Okay, so be careful to note any restrictions. And you've probably forgotten by now, but the restrictions are the places where the denominators could potentially equal 0, because in math we're not allowed to divide by 0. Okay, Okay, so let me show you what I mean here. This is actually checkpoint 2 from the book. So as you're reading, if you do the checkpoints, you'll be pretty good by the time you start watching the videos. Anyway, solve the equation 5 over 2x equals 17 over 18 minus 1 all over 3x. Okay. So what we need to do for the restrictions is to take any denominator that has a variable, like this guy, and set those equal to 0. So 2x equals 0 and solve. Okay. These will give us restrictions. So if you put in x equals 0 into that first fraction, it won't work because you'll have division by 0. So you kind of, I know you said x equals, x can't be 0 at the end of the day. If we take the other denominator, you'll get the same restriction. So overall, the answer, when you get to the end, the answer, you kind of have to check it with your restrictions and make sure you didn't get a restricted value. If you did, you have to kind of eliminate or kick that answer out of the answer pool. Okay, so anyways, let's get the LCD. The smallest number that's divisible by the denominators. So I need something 18, so you're thinking 18, and then you need an x as well. Okay, so 18x. And if you don't see that, I mean, it's, again, it's the least common denominator. 18 is what, 2 times 3 times 3. So each one, the first guy needs a factor of 3 and 3. So if I was forming the LCD, I would multiply top and bottom by 9. Okay, and I would get it. So, but hopefully you appreciate. Yeah, I didn't magically come up with the LCD. Okay, it's from our previous work. Okay, I'm gonna multiply both sides by this LCD. So on the left, I have 18x times 5 over 2x. On the right here, I'll have 18x times 17 all over 18 minus 18x times 1 all over 3x. Okay. The x's here, 2x will go into 18x 9 times, so 9 times 5 is 45. On the right side, 18 go in the 18 one time, so you'll just get x times 17, or 17x. Here you get 3x, and the 18x is 6, so minus 6 times 1 is just minus 6. Then you want to get the variable stuff on one side, all the constants on the other, so I'll just add 6 to the other side. And then I like to flip-flop the equations. I mean, normally it would be 51 equals 17x, but I generally will skip that step and just write 17x equals 51. Divide both sides by 17, and then x will equal whatever, I think it's 3. Okay, you're not done now. Because we have those variable issues, you need to check your answer with the restrictions. So, visually just look back, okay, this isn't 0, so this finally then, this must be my answer, x equals 3. Okay, let's look at some more. So here's 14. 7 all over x plus 1 equals 5 all over x minus 3. Now you may have been sort of trained to cross multiply in these cases. We just want to be consistent with what we're teaching though, so we're going to multiply both sides by the LCD, which in this case we need a factor of x plus 1 and then we need a factor of x minus 3. Okay, so I'll be multiplying by that. Let's get the restriction while we're here. So I need to set each denominator equal to 0 and solve. So x can't be negative 1 and x can't be 3. Okay, so just all of our kind of information. Let's box that up. Multiply both sides by x plus 1 times x minus 3. So we get the x plus 1, x minus 3. There's no real distribution here, so we could just kind of do our simplification. End up with 7 times x minus 3. And on the right side, the x minus 3's cancel. And you get 5 times x plus 1. Distribute here, so I have 7x minus 21, and distribute here, so you get 5x plus 5. Move, I want to get the variables all on one side. Oops, minus 5x. So I get 2x minus 21 equals 5. Then move the 21 over, and you get 2x equals 26. Finally, we're dividing by 2. And as usual, you're not done. Go back and look at the restrictions. So long as this answer is not -1 or 3, you are good to go. So it is not either of those. Okay. Let's look at 22. So we have x plus 3 over x equals 19 over x. So the LCD of all those guys just need an x, right? And then for the restrictions, set x equals 0, so x can't be 0. Okay, so multiply both sides by x. On the left side, I need a distribution. Uh, 19 over x times x, the x's will cancel, and you just get 19. So let's just leave it like that. On the left here, x times x is x squared, plus x goes in x one time. 1 times 3 is 3. On the other side, I have 19. Move the 19. So this is quadratic, right? So you don't want to move the 3. You want to move the 19 to set it equal to 0. So I'm going to move the minus 19. Squared minus 16 is 0. That's a difference of squares. So I can rewrite that as x minus 4x plus 4. And then you set each equal to 0 and solve. Okay, so x is 4 or x is -4. Check them against the restriction. The restriction is 0, so both of these solutions will work. Okay. The next problem is the video quiz. Video quiz. So this is 2 over y minus 2 equals y all over y minus 2 minus 2. The LCD, I'm going to need to multiply by, so a y minus 2. And then for my restrictions, I have to take the y minus 2 and set it equal to 0. So y can't be 2. All right, so I'm going to multiply both sides by y minus 2. Okay. On the left here, these y minus 2's will cancel. You just have 2. On the right, I will write out the distribution. So write it like that. Okay, so 2 equals, so the y minus 2's will divide out. And you just have 1 left over, or 1y. And then you have to distribute this minus 2 to that. So minus 2y plus 4. Combine like terms, so minus y plus 4. I'm going to move the y to the right, or sorry, move the y to the left, and then move the 2 to the right. Okay, I'm going to do this all in one foul swoop, okay, if you allow me to. So I'm getting y equals 2 as my solution, and that's bad news, right? Because we can't have y equaling 2. Okay. Y equal 2 is our only potential solution. So unfortunately, because it's restricted, we have no solutions. Okay, so you just write no solution. Okay, sometimes you can get like 2 answers and one of them won't work but one will. You get 2 answers and neither of them will work. You can have one answer and it doesn't work. You can have one answer and it does work. There's really no rhyme or reason to it, so don't overthink these in the end. But usually, there's not a lot. This doesn't happen all this. No solution cases doesn't happen very often. So on a test, if every answer is coming out no solutions, odds are that's probably user error, I guess. Anyways, let's look at this guy, and then we'll go on to something else. X squared minus 16. All right, so the LCD, let's get that out of the way. I need to get rid of the x plus 4. or I need a factor of x plus 4, a factor of x minus 4, and then the x squared minus 16 is basically x minus 4 times x plus 4. Okay, so we don't need to multiply in anything more than that. The restriction values then set x plus 4 equal to 0. So x can't be negative 4. And then set x minus 4 equals 0. So x can't equal 4. Okay, so that will be our restrictions. Okay, so multiply both sides by our LCD, which is x plus 4 times x minus 4. Okay, so on the left here, I have x plus 4 times x minus 4 times 1 all over x plus 4. Plus, I'm just writing it all out, hoping that maybe that'll help some of you. Maybe not. On the right, this is the same as this, right? So we can just write 22. Okay. So the first multiplication in this distribution, the x plus 4s will cancel, and you're just left with x minus 4. The second distribution, the x minus 4s will cancel. You just be left with x plus 4. On the right, you have 22. Combine like terms, so x plus x is 2x. Negative 4 plus 4 is 0. Divide both sides by 2, and you're just getting 11. Check it with your restricted values. Okay, it's good. And circle it, and then you're done. Okay. The next section is on these things. Sometimes in math circles we call them literal equations, but you see them all the time in like physics and biology and all your science type classes. Okay. And oftentimes we need to rearrange them to solve for something else. Right? It'll be given in terms of one variable, and you need to solve it for some other variable. So the way this works is you kind of isolate whatever variable they ask you to. So maybe there'll be like 4 variables, and they want you to isolate one of them. Okay, so isolate your desired variable. Okay. And I'm pretty sure most of these formulas, they look weird, but they all come from physics. So let's look at example 8. Physics or whatever, biology, chemistry. Okay, so example 8, 1 all over p plus 1 all over q equals 1 over f. And then they want you to solve for p. Okay. The first thing you're going to do when you see this is get rid of those fractions. So use all the techniques we've been using to get rid of the fractions. And so in this case, our LCD is going to be PQF. Right. We don't have to worry about restrictions here usually in this context. We'll just multiply. Okay, so here multiply to PQF. On the other side, you do the same thing. Okay, so on the left, I'm going to write it out again. I know in the previous section I didn't write out my distributions, and I was worried about that, so I just want to do that for the sake of completion in this video. On the right, clearly we can remove the factors of f, and you just get PQ. Okay, so let's simplify now. PQF times 1 over p, the p's will cancel out, leaving you with QF. PQF times 1 over q, the q's will cancel out, and you'll just be left with PF. And then on the right side, you just have the PQ. Okay, what are we solving for again? P. So I'm going to get anything that has a factor of p on one side. So there's one here, and then there's one here. So I'm going to move this guy to the other side. So I'm going to subtract PF from both sides. And I'm going to flip-flop sides. So I'm going to have on the left, or sorry, on the right, I'll have PQ minus PF, right? And then on the left, I would have the QF. But let's just put the QF on the other side. That's perfectly legal. Okay. So what the heck did I do? I rewrote it. QF equals PQ minus PF. And then I just switch the sides. Okay, and I do that a lot in my later classes. Like I won't even mention it. I'll just expect students to be able to kind of do that in their head. So you see what I did? I just switched the left and the right side. Everything's exactly the same. I just put the left side on the right and the right side on the left. Okay, So hopefully I didn't. I'll try. I'm going to try to start doing that these kind of moves a little bit more, and not have to. Okay. So anyways, here I can divide a. There's a common factor of p, so you can factor that out, and you just have q minus f left. And then in the final step, I can divide both sides by the q minus f. Okay. So on our left side, you're just left with p because these divide out. And on the right side, you have qf all over q minus f. Okay. Okay. Let's do the same problem and solve for a different variable. Okay. So 50, 1 over p plus 1 over q equals 1 over f, but this time we want to solve for q. And maybe even pause the video and try it yourself and see if you can get the answer that I'm going to get. Okay, because the process should be very similar to what we did in the last problem. Okay. So anyways, I'm going to get my LCD here, and again it's PQF. So I'm going to multiply this by PQF, multiply this by PQF. Okay, distribute. So I have PQF times 1 over P plus PQF times 1 over Q. And over here, the F's will cancel this time, and you're left with PQ. Okay. On the left, these P's will cancel out. Sorry, it seems like I'm mixing up my left and my right so an awful lot the older I get. The Q's divide out in the second term, so I get PF. And then when I'm solving for Q, right? So I want to get all the Q's on one side, so I'm going to move this PQ over. Or you don't even have to do that. You can move the QF over and then flip-flop sides. Okay, so I'm going to move the QF over, and then I'm going to flip-flop sides. So you'll have PQ minus QF equals PF. Okay, so flip-flop. Then you could factor out the Q from these two terms. So you'd have a Q times P minus F. On the right, you have PF. Divide both sides by P minus F, and you should be done. So Q at the end of the day will be PF all over P minus F. Okay. One more, and then we'll go to my math lab. Here's 54. I have big F equals big G times m sub 1 times m sub 2, which are different, all over d squared. And we want to solve for m sub 2. Okay, this is formula from physics for force due to gravitational pull between objects. And you got to be careful in my math lab. You got to make sure that you don't write a lowercase letter when you mean an uppercase letter. So I can't like replace big F, the capital F, with little f. You can't pull that stuff. My math lab will count it wrong. Okay, so anyways, let's go ahead and solve. First, I'm going to get rid of the d squared by multiplying both sides by d squared. Just get rid of the fractions. So I'll have f d squared equals, these d squares will cancel, big G m1 m2. M sub 1, M sub 2. Now I'm going to divide by everything except the M2. So G M1, G M1. And then finally flip-flop sides as well. So you'll end up with M2 over here, and then FD squared all over big G little m sub 1. Okay. Okay, let's go over to my math lab. Let me make sure I give you my video quiz. Did I give you a video quiz? I don't remember making a big deal out of it. Yeah, video quiz right here. It's number 32. Okay, so let's go to my math lab. Make sure yes. Okay. I don't know why this problem is in my math lab. I just wanted to make sure you know. It's a simplify. I don't know why they're making you do this. This is like a 7.4 problem. I don't know why it's in here. I need to get rid of it, but it's in there. So just be aware. Sure, let's try this one. Okay. So we'll do like 27 to 33. But I'm going to skip that one. You have to do it, but I don't. Okay, sorry. Okay. It'll give you a good review. So here we have x squared minus 12. I'm going to go ahead and factor that denominator so I can get the LCD. X and x has to be plus minus, and then 6 and 2, right? With the negative 1, 6 and 2. Okay, the other side, 1 plus 8 all over x minus 6. Okay, so my LCD in this case looks like I need an x plus 2 and I need an x minus 6. I need to worry about restrictions, so set each part of the denominator equal to 0, each denominator equal to 0. So x plus 2 equals 0, x can't be negative 2, x minus 6 equals 0, so x can't be 6. So just those two restrictions. Let's box that off. Okay, so I need to multiply both sides, and here we go. I'm going to smush hopefully this won't blow anyone's mind, but I'm going to x plus 2 times x minus 6, and then over here as well. So x plus 2, I really had to smush it in, I'm sorry. Write it all out, but okay, on the left the x plus 2's will cancel and the x minus 6 is cancel, just leaving it with that numerator x squared minus 12. On the right, if I distribute, the first distribution, nothing happens. I just get x plus 2, x plus 6, x minus 6. In the second distribution, the x minus 6 will divide out. So you'll have 8 times the x plus 2. Okay. Now I have some foiling and some distributions. So I have x squared minus 12 equals first x squared outer minus 6x inner plus 2x is minus 4x, then minus 12, and then distribute here plus 8x plus 16. Start combining like terms on the right side. X squared minus 4x plus 8x is plus 4x. Minus 12 plus 16 is plus 4. The x squares will cancel out if you subtract x squared on both sides. Then you got minus 12 equals 4x plus 4. Isolate the variable term, so I'm going to minus 4 on both sides and flip-flop sides. So I got 4x equals negative 16. Divide both sides by 4. Yeah, it's like negative 4. Compare that to your restrictions. It's not restricted, so that should be your answer, negative 4. And then there's this, yeah, this will just be a review question for you. I apologize that it's even in there. I'm not the one that writes up the homework problems. I do edit them. I go in and throw unnecessary questions out, but I missed one, sorry. Anyways, it'll be good practice. Y plus 4 minus 1 all over 4 minus y equals 2 all over y squared minus 16 is really y minus 4 times y plus 4, right? Okay. The second denominator is one of those opposite scenarios. So what I'm going to do first is just rewrite it. So change the minus to a plus, and then rewrite 4 minus y as y minus 4. Okay. Then our LCD and so on up here on the top left. LCD, y plus 4, and then a y minus 4. Okay. And then restrictions, so you're setting denominators equal to 0. Okay. Okay, so let's multiply through both sides by y plus 4, y minus 4. Okay, so this first distribution, the y plus 4s will cancel. And you'll just have 5 times y minus 4. And the second distribution, the y minus 4s will cancel. And you just have 1 times y plus 4, which is just y plus 4. On the right side, all that will cancel and you'll just be left with 2. All right. Now I have some distributions. So I have 5y minus 20 plus y plus 4. Combine like terms, so I have 6y minus 16 equals 2. Move the constant, the 16, to the right side. So I have 6y equals 18. Divide by 6. So y is 3. Check it with the restrictions. No. The only restrictions are 4 and -4. So 3 is my solution. Restriction, we have a cost function. The average cost per wheelchair C for the company that manufactures X wheelchairs per month. So X is the number of wheelchairs per month. C is average cost. Average cost per wheelchair. Sorry about my handwriting. So big C equals 300x plus 500,000 all over X. How many wheelchairs per month can be produced at an average cost of $350 per wheelchair? Okay, so I'm going to put 350 in for C. So that's what they're saying. Average cost they're saying is 350. And then they want you to find X, the number of wheelchairs that can be produced for a month. Okay, so I'm going to plug 350 in for C. You just plug that in there. And then the other side stays the same. And then I'm going to solve this formula. And, the LCD here is just X. The restricted value 0. X can't be 0. Multiply both sides by X. So on the left, you'll just have 350x. On the right, the x's will cancel, and you'll just be left with the numerator, 300x plus 500,000. Then I'm going to subtract the 300x from both sides. I get 50x equals 500,000. And then divide both sides by 50. And you get x equals, I don't know, one of those will go away. So 5, and it'd be 1, 0, 0, 0. It looks like about 10,000 wheelchairs per month. A lot of wheelchairs, unless I messed up my arithmetic there. But what's next? A grocery store. They sell 4,000 cases of canned soup per year. By averaging cost to purchase soup and to pay storage costs, the owner has determined that if X cases are ordered at a time, so X is the number of cases ordered, the yearly inventory cost, C, so this is inventory cost, can be modeled by the formula C equals 10,000 over X plus 3X. How many cases should be ordered at a time for a yearly inventory cost to be $350? So it's very similar to the last problem. They're giving you one variable and they want you to solve for the other. Okay, so in this case, again, they're giving you the C value, and then they're probably going to want you to compare something. Okay, so let's put 350 in for C into their given model. Here the LCD is just X. We don't really have to worry about the restriction too much. Let's just multiply both sides by X. The restriction 0 if you really need to know. But anyways, I'll have 350x. Here when you distribute the x's in the first distribution, the x's will cancel. You'll just be left with 10,000. And the second distribution, x times 3x is 3x squared. Okay. This guy is quadratic, so we want to set it equal to 0. Okay, so you'd end up with 3x squared minus 350x plus 10,000 equals 0. I flip-flop sides in there, so subtract the 350 over and then flip-flop sides. I don't think I can pull out a common factor of 3, which is very sad. I'm just stuck with factoring this thing. So it has to be 3x, it has to be minus minus, this has to be x, and then I'm thinking probably like 100 and 100, right? Or some variation of that. How many times does 100 go in there? 100 times, 100 times 100. How about 50 times something? 1, 0, 1, 2, 3 divided by 50 is 200. That's not going to get the job done. 50 times 3 is 150. Yeah, that will work. Okay, so I'm going to put the if I put the 200 here, and then I think the 50 here, the outer terms will be 150, the inner will be 200, and then when you add them, you'll get the 350. Okay, so 3x minus 200 equals 0, and then x minus 50 equals 0. So you're looking at some weird fraction here. And then from this guy, the number 50. Maybe there's a restriction here. Identify your solutions as points on the graph. The graph is shown to the right. How many cases? And they want, yeah, so we have more than one answer, and then they want us to round the 200 thirds. Okay, so 200 divided by 3 is 66.6 repeating nearest integer. So 67 and then 50. Identify your solutions as points on the graph. Well, okay, so the x is the 67, and then the y would be the 350. Right? And then you could think, okay, that's also true for 50, comma 350. So the order of pairs are x, comma c. So c is like y. Okay. And anything else? No. Okay. This one's just like a hard equation. Okay, so let's see this guy. I'm going to go ahead and factor denominators. 2x, it's got to be 5 here, right? Minus x and 1. So does that work? 10, negative 10 minus 1x is, yeah. On the other side, 7 all over 2x. This time it's plus minus, and we want the plus 1 to be positive, and this one's negative. So you'd get positive 10x minus 1x would give you the positive 9x. Then we got 2x minus 6. This is just a difference of squares. Okay, so first off, thinking of the least common denominator here, the LCD to the top right of my screen. You need a 2x minus 1, you're going to need an x minus 5, and you're going to need an x plus 5. Okay. So if you allow me to, I'm going to smush that material in rather than rewriting everything. So I need a 2x minus 5, an x minus 5, and an x plus 5 on both sides. Okay. On the left, the 2x minus 1, or it's 2x minus 1, not 2x minus 5. So the 2x minus 1s will cancel, and then the x minus 5s will cancel, and you're just left with x plus 1 times x minus 5. Okay. Here, on the first distribution, the 2x minus 1s will cancel, and then the x plus 5s will cancel. And you just be left with x minus 7 times x minus 5. Okay. Minus basically the 2x minus 6 times whatever's left in that case. And in that case, the x minus 5 will cancel, and then the x plus 5 will cancel. And you'll just be left with this 2x minus 1. Okay. Okay, I need to do some FOILing. So I have x squared minus 5x plus 1x is minus 4x, and then minus 5. On the right, x squared minus 7x minus 5x, so that's x squared minus 12x plus 35, minus 4x squared minus 12x minus 2x is minus 14x, and then plus 6. Well, I forgot my restricted values too, so let me really quick. So 1/2, 5, and negative 5 are restrictions. Okay, box that off. What do we got? X squared minus 4x minus 5 equals x squared minus 12x plus 35. Now I can finally distribute. Minus 4x squared plus 14x minus 6. Okay, so we got x squared minus 4x minus 5. Start combining some like terms. That's minus 3x squared plus 2x plus 29. Okay, I'm going to move the stuff on the right to the left. So plussing 3x squared, I'll get 4x squared. Subtract 2x, you get minus 6x. Subtract 29, you get minus 34. Looks like I could factor out a 2 from all that material. So I get 2x squared minus 3x minus 17. I totally feel like I've made a mistake, right? So what happened? Did I copy it right? That would be the first kind of issue. I think I got it right. Oh, no, that's... Oh, it's the x plus 5 right here. So that's one issue. Let me see if there's anything else. The x minus 5's cancel, and I'm left with an x plus 5. So first distribution, the 2x minus 1, and the x plus 5. So I have an x minus 5 for that one, yep. Minus the 2x minus 6. So the x plus 5 and the x minus 5 will cancel, leaving me with the 2x minus 1 times 2x minus 6. Okay, so I think that's good. All right, so the signs are wrong on this. So anyway, it would be plus x plus 5x. That would be plus 6x right here, and then plus 5. So plus 6x plus 5. I'm sorry, plus 6x plus 5. And then I can move something over. Whoop. Okay, so adding the 3x squared gives me a 4x squared. Subtract the 2x, I get 4x. Subtract, so that'll be minus 24. You can factor out a 4 from all of them. And then we could factor that thing, the x plus 3, x minus 2. And then we'll have two solutions. X plus 3 is 0, or x minus 2 is 0. So x is negative 3, or x is 2. Checking them with the restrictions, we're good. So let's get back over to my math lab. Okay, so what did I say? 3 and 2, negative 3 and 2. One more. So we got a funny variable. So this is like a literal 9x plus 1 all over r plus 7 equals x. Find r. So the solution is negative 9. So we want x to be negative 9. Okie dokie. I'm going to multiply both sides by r to get rid of that fraction. So this times this will just give me 9x plus 1. This times this will give me plus 7r. On the right side, I'll get xr. And I get all the r material on one side, so I have 9x plus 1 equals xr minus 7r. Then you could factor an r out of that material. So 9x plus 1 equals r times x minus 7. Then I could divide both sides by x minus 7. So I have r equals 9x plus 1 all over x minus 7. And I want the solution to be x equal negative 9. So what I'm going to do here is just plop that in for x. Okay, so r would equal 9 times negative 9 plus 1 all over negative 9 minus 7, which is negative 81 plus 1 all over negative 16, which is negative 80 all over negative 16. I don't know what what that is. 5 maybe? Yeah. Okay, so 5. Okay. Let's see if there's any crazy literal ones. It doesn't seem like I did any literal problems. Let's see if there's I don't see any of them. They're not in this section. Well, that seems like a waste. Well, okay. So, well, anyways. Oh, well, okay. Here's one. Good. So P all over big R equals Y, big Y over V, and we want to solve for R. Okay. So I'm going to multiply both sides to get rid of the denominators by the LCD of RV. Okay. So multiply over here by RV, multiply over here by RV. So on the left, the R's will cancel, and I'll just be left with VP. And on the right, the V's will cancel, and I'm left with RY, or YR if you'd rather. Okay. Then I'm just going to divide both sides by Y and flip-flop sides. Okay. The R will equal VP all over Y. So again, what's important here, I'm hoping that you pick up, is that you need to, if it's a capital variable, you need to leave it capital in your answer, or MyMathLab will count it wrong. Yay. That's kind of like the PQR one. Oh, here's a weird one. That's a B bar is how they will say it. So it's Q equals little b plus B bar. Okay, all over S for little b. Sometimes they just run out of variables, so they'll start putting bars, and they'll go B sub 1, they can go B bar, they can go B hat, they can go B double bar. I've seen they can have B vectors with little arrows over top of them. So just be aware that all these things exist. So anyways, I'm going to multiply both sides by S. So I'll have SQ equals B plus B bar. Subtract B on both sides and flip-flop equation. B, whoops, I solved for B bar. I'm sorry. I want to solve for B. So I'm going to subtract B bar from both sides. And I'll get SQ minus B bar equals B. Flip-flop the sides. B equals SQ minus B bar. Okay. So I have SQ minus, and then you see this button down here. I should give you a bar over top of it. Okay. Make sure you use a little c, not a capital C in that one. I'll do one more and then we'll call it quits. Okay. So let's just do this one. A equals QC all over Q plus C, and we want to solve this for C. Okay, so first I'm going to multiply both sides by Q plus C. Okay, so I'll have Q plus C times A equals QC. I need to get all the all the C material on one side, so I'm going to distribute here and then move the AC. Okay, so I have AQ plus AC equals QC, and then I'm going to move the AQ over, so I'll have AC equals, whoops, I'm solving for C. I'll move the AC over. Okay, so I'll have AQ equals QC minus AC. And then I could factor the C on the out of the two terms on the right. So I have AQ, pen froze. I can factor C out here, and I got Q minus A, and then divide both sides by Q minus A. So I'll have AQ all over Q minus A equals C, or if you'd rather, C equals AQ over Q minus A. Okay, so a fraction of our AQ all over Q minus A. And thank you for watching as usual, and we will see you next time.